today we're looking at 4.5, which is limits at infinity, which means limits are back. So it's important that you recall some things about limits, like when do you drop the limit statement, etc., right? Only when you're quote unquote plugging in, which is going to look a little differently here. But it's also important to remember that limits, not only can you do it algebraically, but you can also look at a graph or a table. So that's where we're going to start. Okay, so this section discusses quote unquote end behavior. So basically what happens to the far right of a graph, what happens to the far left of the graph as x values get really, 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 really big, right? So very far to the right, or really, 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 really small, far to the left, right? Remember we talked about this as being increasing or decreasing without bound. All right, so you can see in the table, the x values are getting larger and larger and larger, and you can see that the y values are approaching an actual number, right? In the graph, that shows up, right, as this limiting y value, right, that is getting closer and closer to basically what looks like a horizontal asymptote. Okay, so we can write this idea as the limit as x goes to negative infinity, or the limit as x goes to infinity for this particular function would equal 3, right? And I think that this is important to realize that the statement, the limit as x goes to negative infinity for a function equals L, or to infinity equals L, means that the limit actually exists, right? And that the limit equals L, okay? All right. So here we go. This is our definition of horizontal asymptotes. Okay. So the line y equals L, remember horizontal line would be a y equals, is a horizontal asymptote when the limit as x goes to negative infinity of the function equals L, or the limit as x goes to infinity of the function equals L. Okay, so we can determine from this then that the graph of the function can have at most 2 horizontal asymptotes, one to the left and one to the right. Okay, limits at infinity have many of the same properties of limits that we talked about before. Like for instance, you can split it up with addition, right, or with multiplication, right, and that would also work at negative infinity. Okay, there's one more theorem that's pretty helpful.